All right, so you want to make 2D games with Unity, right? Well, buckle up because we're about to unpack a beginner's guide to 2D game development.
With Unity.
With Unity, yeah.
Huh.
It's amazing how much goes into even a simple game.
Oh, yeah.
Like the size of a monster in pixels. It actually translates to a size in centimeters within the game world.
Wow.
It's those kinds of details that really make a game feel real. To help us break it all down, we've got our resident expert in synthesizing information.
Well, it's great to be here. It's exciting to see how this guide makes game development accessible to everyone.
Oh, yeah.
It breaks down complex ideas step by step, so even if you're just starting out, you'll be able to follow along.
Yeah, the first thing that struck me was the guide's focus on Unity. I know it's a popular game engine, but I had no idea it was used for so much more than games.
Oh, really?
They even use it for things like interactive architectural walkthroughs. That
Yeah.
blew my mind.
Yeah, Unity's versatility is really impressive. It provides this powerful framework for creating interactive experiences, and those pre-built modules, like the physics engine, they take care of all the complex stuff behind the scenes. Imagine trying to code gravity and collision detection from scratch. Unity handles that for you, so you can focus on the creative aspects of your game.
Okay, that makes a lot of sense. Now let's talk about 2D versus 3D. I always thought 2D games were well flat, but the guide mentions that even 2D games sometimes use 3D models and perspective. It's like a mind-bending trick.
It definitely challenges our perceptions of what 2D really means. The guide dives into different 2D game perspectives. For example, orthographic 3D gives you that classic bird's eye view you see in a lot of strategy games.
Yeah.
And then there's 2D gameplay with 3D graphics, where the visuals might be three-dimensional, but the gameplay itself is restricted to two dimensions, like in a side-scrolling platformer.
Right. Some games use 3D models, but the action all happens on a 2D plane. It's like a clever visual illusion. Now let's get into the actual process of building a game world. I was impressed by how much the guide emphasizes organization and planning from the start. It's like laying a strong foundation before building a house.
Absolutely, a solid structure is key. The guide recommends using a root object in the scene. It's like the main folder that keeps all your game elements organized and manageable.
And then comes the fun part, building the background and the ground. I loved how the guide explained techniques for using repeating images to create the feeling of a vast, continuous world.
Yeah, it's like creating a seamless, never-ending landscape. You can really see the art of game development coming through in that process.
There was this really neat tip about setting the image's pivot point to the left for easier placement. Little details like that can save so much time and frustration. And I found it fascinating how the guide connects pixels in an image to units in Unity space. It's like each pixel becomes a building block in your game world.
That connection between pixels and units is all about scale and proportion. By understanding that relationship, you can make sure that everything in your game looks and interacts realistically.
Speaking of efficient building, the guide really stresses the importance of prefabs. Those are like pre-made templates for objects in your game, right?
Exactly. Think of them as reusable building blocks. Instead of creating every tree or rock from scratch, you can create a prefab and reuse it throughout your game, saving a ton of time and effort.
Now let's move on to camera control. This is where things start to feel really dynamic.
Huh?
The guide goes deep into how to control the camera in Unity, and it's more complex than I imagined.
Yeah, camera control is crucial for shaping the player's experience. It's like directing a movie. You're guiding the player's view and creating that sense of immersion. The guide explains things like aspect ratio, which determines how much of the game world the player sees on their screen. For this particular game, it's 16.9, the same as most widescreen TVs.
The guide also talks about different camera movements like panning, zooming, and rotating. Those really add to the feeling of being in the game.
Right. And to make the code more organized and manageable, the guide recommends separating the code for camera control from the code that handles player input. It's like keeping your tools organized in separate drawers.
So you're not mixing up the instructions for how the camera moves with the instructions for how the player controls it. That's smart.
Exactly. And the guide even mentions clever techniques like using the math.clamp function to keep the camera within the boundaries of the game world. It's like setting up invisible walls so the camera doesn't wander off into empty space.
I've definitely played games where the camera gets stuck or goes out of bounds, and it's super frustrating. Now let's dive into the physics of the game. The guide's explanation of how motion is simulated in Unity was mind-blowing. It's like giving your game objects a life of their own.
It's all about simulating the laws of physics within the game world. The guide breaks down the key components: the rigid body 2D, the circle collider 2D, and the RB.velocity variable. These work together to make objects move and interact in a way that feels natural and believable.
And then there's the input get key function. That's how the game reads what keys the player is pressing right. The guide mentions that the code for launching a projectile and making it move through the air can get pretty complex.
Oh, yeah. Simulating projectile motion accurately requires you to think about things like gravity, the force of the launch, and even air resistance. It's like calculating the trajectory of a real-world projectile, but you're doing it all in code.
Speaking of projectiles, the guide goes into detail about different special attacks that they can perform. There's a speed attack for the bird-shaped projectiles and a cluster attack for the giraffes and elephants.
What's really neat is how these special attacks are implemented using messages and separate scripts. It's a great example of modular programming where you break down complex features into smaller, more manageable chunks of code.
So each attack has its own little piece of code that gets activated when the player triggers it.
Exactly. That keeps the code organized and makes it easier to add new attack types or modify existing ones without messing up the rest of the game.
The guide even explains how to create those cool cluster projectiles with details about scaling rotation and using prefabs. It's amazing how all these small details come together to make the gameplay so engaging.
It's all about attention to detail. Even something as simple as the size and rotation of a cluster projectile can have a big impact on how the game feels to play.
You know, one thing I never really considered was the challenge of adapting a game from mouse input to touch screens. It's a whole different way of interacting.
Absolutely. The guide acknowledges that challenge and explains different types of touch inputs. You've got single touch, double touch, and each touch goes through phases like began, moved, and ended. It's all about translating those touch interactions into actions within the game. The guide even explains how they use something called raycasting to detect whether the player is touching a specific object. Imagine an invisible laser beam shooting out from the player's finger. That's basically what raycasting does. It helps the game understand what the player is trying to interact with.
That's so cool. So instead of relying on the exact spot where the player touches the screen, you're using this virtual laser to figure out what they're trying to select.
Exactly. It's a really clever way to make touch controls more intuitive and responsive.
The guide also mentions disabling mouse input simulation on touchscreens. It makes sense to have a dedicated input system for each type of device to avoid any weird behavior.
It's all about providing the best possible experience for the player no matter what device they're using. Now that we've seen how touch input works, let's shift gears a bit and talk about how the guide tackles the challenge of simulating motion in Unity. It starts by diving into the fundamentals of scripting in C#, those lines of code that bring our game to life.
Oh yeah, the scripting. I remember the guide talking about the start and update functions. Those are like the building blocks of any game script, right?
Exactly. The start function is like the opening act. It runs only once when the game begins setting the stage for everything that follows. Then you have the update function, which is the heart of the game. It runs continuously every single frame, constantly checking for input updating positions and making sure everything runs smoothly.
It's like the conductor of an orchestra, keeping everything in sync.
Hmm.
The guide emphasizes the importance of thinking logically when you're writing code. It encourages you to break down the problem of movement into smaller steps.
Right. It's like solving a puzzle.
Yeah.
If you want to move an object up when the W key is pressed, you need to first figure out how to detect when that key is pressed and then how to apply an upward force to that object.
And that's where the input get key function comes in. It's like the game's way of listening for instructions from the player.
Exactly. And once the game knows the W key is pressed, it needs a way to translate that into movement.
Yeah.
That's where the rigid body 2D component comes in. It's like giving your game object physical properties, allowing it to react to forces and move around in a realistic way.
So it's not just about magically teleporting the object upwards. It's about simulating the forces that would actually cause it to move that way.
Yeah.
That makes the game so much more immersive.
Exactly. The guide explains how to use the rb.velocity variable that's part of the rigid body 2D component to control the object's speed and direction. By changing this variable, you can make the object move in different ways, making it react to the player's input.
The guide also mentions conditional statements, like if statements. It's like giving the game a set of rules to follow, right?
Absolutely. Conditional statements are like the logic gates of the game. For example, you could say, if the W key is pressed, then move the object upwards. It allows the game to make decisions based on the player's input or other events happening in the game.
Moving on to Chapter 3. The guide really gets into the action. This is where we learn how to create and launch projectiles, which are such a staple in so many games.
This is where the game starts to come alive. The guide introduces the concept of prefabs, those pre-made templates for game objects that we talked about earlier. You can use them to create all sorts of things like projectiles with unique looks and behaviors.
It's like having a blueprint for each type of projectile.
Yeah,
It makes the process so much more efficient.
right. And then there's the physics of launching those projectiles. The guide explains how to use the rigid body 2D component and the add force function to simulate that launch, taking into account factors like gravity and the initial force applied to the projectile.
It's fascinating how you can code those real-world physics into the game. It's like you're creating a mini universe with its own set of rules.
The guide also emphasizes the importance of state variables. These are like little flags that track the status of a game object. For example, you could have a state variable that tells you whether a projectile's been launched, whether it's being held, or whether it's controllable by the player.
That makes sense. You need a way to keep track of what's happening with each object at any given moment.
Hmm.
And speaking of states, the guide goes into detail about the different phases a projectile goes through. Like from being stationary on the ground to being launched and eventually disappearing.
It's like a life cycle for the projectile. The guide explains how to use code to manage those transitions smoothly, ensuring the projectile behaves realistically at each stage.
It also mentions the use of messages, which is how different parts of the game can talk to each other.
Yes. Messages are like little notes passed between different scripts. For example, when a projectile is launched, it might send a message to other parts of the game, letting them know it's on the move.
It's like a chain reaction triggered by the launch.
Exactly. And it gets even cooler when you start adding things like sound effects. The guide explains how to implement sound effects for each action, which really adds to the immersion.
I love how sound design can really bring a game to life. A satisfying whoosh when you launch a projectile or a powerful impact sound when it hits its target. It makes all the difference.
Absolutely. And the guide provides a clear example of how to do that using the audio source, play clip and point function. It's surprisingly straightforward once you see it in action.
And one of the most exciting parts about projectiles is the concept of special attacks. The guide explains how to create those unique abilities, like a speed attack that makes the projectile move faster, or a cluster attack that splits it into smaller fragments.
This is where you can really get creative with game design. The guide shows how to implement these special attacks using separate scripts and messages, making the code clean and easy to modify.
It's like each special attack gets its own instruction manual, so you can tweak and experiment without breaking the rest of the game.
Precisely. And the guide doesn't just tell you how to code it, it also shows you how to represent the projectile's path visually using dots, which gives the player important feedback and adds to the visual flair of the game.
Those visual cues are so helpful for understanding the game's mechanics. The guide also emphasizes the importance of organizing all the game objects in a hierarchical structure like a family tree to keep everything tidy and easy to manage.
It's like organizing your files on a computer. You wouldn't want everything scattered around randomly, would you?
Definitely not. Now, we can't forget about the slingshot. That's the key to launching those projectiles. The guide goes into great detail about how to create and control it.
The slingshot is a crucial element in this game, and the guide does a great job of breaking down its functionality step by step.
It explains how to create the slingshot visually using sprites and empty game objects to represent its different parts, like the base, the elastic band, and the launch position.
Right. It's like assembling a virtual contraption piece by piece.
And then there's the launcher script, the brains behind the operation. This script controls everything about the slingshot, from loading projectiles to aiming and launching.
It's like the command center for the slingshot. And the guide even shows how to use the line renderer component to draw that elastic band connecting the projectile to the slingshot, adding that extra touch of realism.
I love how those little details make the game so much more immersive.
It's all about making the game feel believable. And then there's the input system that connects the player's actions to the slingshot. The guide explains how to create a script that reads the player's input, whether it's from a mouse or a touchscreen.
So if the player clicks and drags the mouse or swipes their finger across the screen, the script interprets those actions as pulling back the slingshot and aiming the projectile.
Exactly. And when the player releases the mouse button or lifts their finger, the script triggers the launch sequence. The guide even explains how to limit how far the elastic band can stretch, preventing the player from pulling back the projectile too far.
That's important for maintaining balance in the game. It wouldn't be fun if you could just launch projectiles across the entire screen with no effort.
It's about creating a challenge for the player, making them think strategically about their shots.
Wow, we've covered a lot of ground. From building the background and the ground to creating projectiles and the slingshot and even adding special attacks. The game is really taking shape.
It's exciting to see how each piece of the puzzle fits together.
Now I'm curious to see how the guide tackles the challenge of adapting this game for touchscreens. That's a whole other world of input and interaction, And I know it can be tricky to get right.
It's a crucial step in making the game accessible to a wider audience, especially with the popularity of mobile gaming.
Okay, so Chapter 4 of the guide dives right into the differences between touch input and traditional mouse or keyboard input. One of the big challenges is that touch screens can handle multiple touches at the same time, which can be tricky to manage.
It's like juggling multiple inputs at once. The guide emphasizes the importance of recognizing and responding to those unique touch events like pinches, swipes, and rotations.
It's amazing how much you can do with just a few fingers on a touchscreen. It's a whole new language of interaction.
The guide starts by explaining how Unity handles input for UI elements like buttons. It points out that Unity automatically recognizes touch input on those elements, so you don't need to write any special code for them.
That's a relief. It simplifies things quite a bit.
It does, but when it comes to game input, things get a bit more complex. The guide highlights the need for separate scripts to handle touch input, as opposed to the scripts we've already discussed for mouse input.
And the reason for that is because Unity tries to simulate mouse input on touchscreens, which can cause all sorts of problems.
Exactly. By default, Unity translates touches into mouse events like clicks and drags. While this might work for some basic games, it can create conflicts and inconsistencies in more complex games, especially those that rely on multi-touch gestures.
So the guide recommends disabling that mouse simulation on touchscreens and creating dedicated scripts for handling touch input. That makes a lot of sense. You want each input system to be tailored to the specific device.
It's all about providing the best possible user experience. Touch interactions feel fundamentally different from mouse interactions, so you need a separate input system that feels natural and intuitive on a touchscreen.
All right, so let's dive into these touch-specific scripts. The guide starts with the camera touch input script, which controls the camera using touch input.
Right. This script is like the touch-based counterpart to the camera mouse input script we discussed earlier. It handles all the same functions, moving the camera, zooming in and out, but it's specifically designed for touch interactions.
And just like the other touch input scripts, this one also destroys its mouse-based counterpart to avoid any conflicts, right?
Absolutely. You want a clean separation between the mouse and touch input systems to avoid any unexpected behavior.
The guide explains that the camera touch input script follows a very logical process. First, it checks if the game is running on Android, a common platform for touch-based games.
And if it is running on Android, it disables the camera mouse input script, ensuring that only the touch input script is controlling the camera.
That makes sense. You don't want both scripts fighting for control.
Exactly. From there, the script checks for different touch events, like single-finger touches for moving the camera and two-finger touches for zooming and panning.
And those events are managed using state variables, right? Those little flags that keep track of what the player is doing.
Right. You've got variables like single touch and double touch that indicate whether the player is currently touching the screen with one or two fingers.
So if single touch is true, the game knows to look for camera movement commands. And if double touch is true, it knows to look for zoom and pan commands. It's a clever way to keep everything organized.
It really is. And the guide doesn't just tell you what the code does, it actually walks you through how it works step by step. It explains how the script uses the input.touchCount variable to figure out how many fingers are touching the screen at any given moment.
And then it uses the input.touches array to access information about each individual touch, right?
Exactly. Each touch is represented by a touch object, which contains all sorts of data like the position of the touch, the phase it's in, and so on.
The guide seems to focus on the touch.phase property. What exactly does that do?
The touch.phase property tells you the current stage of a touch. It goes through phases like began, moved, ended, and canceled.
So it's like tracking the entire journey of a touch from the moment the finger first touches the screen to the moment it lifts off.
Exactly. It's incredibly detailed, and it allows the script to respond to very specific events within that touch gesture.
So for example, when the touch.phase is began, that's when the script needs to figure out if the player is touching a valid area for camera control.
Right. It doesn't want to move the camera if the player is touching a UI element or trying to interact with the projectile. The guide explains how they use raycasting to make sure the touch is on a valid object.
Raycasting, that invisible laser beam that helps the game understand what the player's touching. So the script shoots a ray from the touch location and checks if it hits the collider of the background or the ground right.
Exactly. It's a really reliable way to handle touch input and make sure the camera only moves when it's supposed to.
The guide then explains how the script uses the player touch.delta position property to figure out how much the player's finger has moved since the last frame.
This is crucial for making the camera movement smooth and responsive. The delta position tells the script how far the player's finger has moved, and that information is used to calculate how much the camera should move.
So the more the player moves their finger, the more the camera moves. It's like a direct connection between the player's touch and the camera's movement.
Exactly. And the guide even explains how to multiply that delta position by a movement speed variable to control how sensitive the camera is to the player's touch.
It's amazing how much detail goes into making these interactions feel natural. I'm starting to appreciate the complexity of designing good touch controls.
It's a real art form. The guide also covers how the script handles two-finger touches for things like zooming and panning. It calculates the distance between the two fingers and uses that to determine whether the player is trying to zoom in or out.
It's like pinching the screen to zoom in on a photo, but in this case, you're zooming in on the game world.
Exactly. And by combining those single touch and double touch interactions, you can create a really intuitive and versatile camera control system for touchscreens.
Now let's move on to the Launcher Touch Input script. This is the touch-based version of the Launcher Mouse input script that controls the slingshot right.
Precisely. It's all about translating those mouse-based interactions into touch-based interactions. And just like the camera touch input script, this one also disables its mouse-based counterpart to avoid any conflicts.
The guide explains that the Launcher Touch Input script follows a simple three-step process in each frame. First, it checks if the player has touched the projectile.
Right. It uses ray casting, that invisible laser beam, to determine if the player's touch is on the projectile.
Then, if the player is holding the projectile, the script checks for finger movement to adjust the aim.
It calculates the touch's delta position, just like the camera script, to figure out how much the player is moving their finger. That information is then used to adjust the aim of the slingshot.
And finally, the script checks if the player's lifted their finger, which triggers the launch sequence.
Exactly. So it's a very intuitive system. You touch the projectile to grab it, you move your finger to aim, and you lift your finger to launch. It mimics the natural motions you'd use with a real slingshot.
It's fascinating how you can translate those real-world interactions into code. The guide also mentions the Special Attack Touch Input script. What does that one do?
That script handles triggering the projectile special attack using touch input. It's a fairly simple script, as it only needs to detect a single touch to activate the special attack. Once it detects a touch, it sends a message to the projectile telling it to execute its special attack.
So it's like tapping the screen to unleash the projectile's special power.
Exactly. It's a very straightforward and satisfying way to implement special attacks on touchscreens.
Wow, so we've covered all the essential scripts for adapting this game to touchscreens. The guide really breaks it down into manageable chunks, making it seem a lot less daunting.
It's all about understanding the core principles of touch input and then applying those principles to specific game mechanics. The guide does a great job of demonstrating that process.
I'm really impressed with how much detail the guide goes into, and I can see how valuable this information would be for anyone wanting to create their own touch-friendly games.
It's a fantastic resource for anyone who wants to dive into the world of mobile game development.
So we've covered a ton of technical ground, from scripting and physics to adapting the game for touchscreens. But the guide doesn't stop at just the technical stuff. It also dives into the world of game design. It even includes tips from the legendary Shigeru Miyamoto.
Miyamoto?
Yeah, the creator of Mario and Zelda.
Oh, wow.
Talk about a deep dive.
It's amazing to see those design principles laid out so clearly. The guide really emphasizes the importance of understanding the player's perspective. It's not enough to just create a game that works technically. You have to create a game that's fun and engaging to play.
Yeah, it's like the difference between building a house and creating a home. One is functional, the other is an experience.
Exactly. And the guide highlights the crucial role of game testers. Those are the people who play the game during development and provide feedback. Their insights are invaluable for catching bugs, balancing the difficulty, and making sure the game is as enjoyable as possible.
They're like the first audience, giving you a fresh perspective on what works and what doesn't. I remember reading a quote from Miyamoto in the guide where he talks about finding inspiration in his childhood experiences, like exploring the woods near his house or discovering a hidden cave. Those experiences shaped his approach to game design.
That's so cool. It reminds us that even the simplest experiences can spark incredible creativity. And the guide goes on to list some essential skills for game designers. Things like communication, teamwork, problem solving, and of course, a healthy dose of creativity.
It's not just about coding. It's about bringing together a whole bunch of different skills and perspectives to create something special. It's like conducting an orchestra where every instrument has its part to play.
Exactly. And when all those elements come together harmoniously, that's when the magic happens.
So as we wrap up this deep dive into 2D game development with Unity, it's clear that there's so much more to it than meets the eye. It's a blend of technical skills, artistic vision, and a deep understanding of the player's experience.
We've explored the nuts and bolts of scripting and physics, the intricacies of touch input, and even touched upon the creative process of game design. It's been quite a journey.
And thinking about all the work that goes into even a simple game makes me appreciate them even more. Every jump, every puzzle, every sound effect, it's all a result of someone's hard work and creativity.
Absolutely. And it might just inspire you to try building your own game someday. The tools and resources are out there, and who knows, maybe you'll be the next Miyamoto creating worlds that capture the imagination of millions.
That's a thought to leave you with. What seemingly simple game do you absolutely love? Now, imagine being the one to bring that game to life. It's amazing to think about all the thought and effort that goes into making these experiences that bring us so much joy.
It's a testament to the power of human creativity and the boundless possibilities of technology.
And on that note, we wrap up our deep dive into the world of 2D game development with Unity. We hope you've enjoyed the journey and learned something new along the way. Maybe you'll even be inspired to create your own game someday. Until next time, keep exploring, keep learning, and keep playing.